In this problem, we are being given an algebraic function, and we're being asked to report where it's increasing and where it's decreasing. So where the slope is positive, where the slope is negative, and also where it has a local max or a local min. So we want to find all those things. It's fairly easy to do that using the derivative. This is one of the great powers of the derivative. It tells you the slope of your function. So what I want to do first is take the derivative of this thing. So let's find f prime of x. So f prime of x, let's see, I'm going to multiply 4/3 out front. So there's a negative sign there, negative 4/3 times x minus 3, and we're going to decrease this by 1, so we get 1/3. I don't have to do anything with the inside because if I were to use the chain rule here, the derivative of x minus 3 is just 1, so I'd be multiplying by 1. So this is actually done there. And the plus 8, of course, becomes 0. So I should have left room for an equal sign here, but this is f prime of x. Now, what we want to do is we actually want to set this to 0 because I want to see where there is a local max or a local min. Once I do that, I can know how many regions there will be to test. So let's set this thing equal to 0. And actually, I can just go ahead and divide by negative 4/3 on both sides. So that just gives me x minus 3 to the 1/3 power equals 0. I can cube both sides, so I get x minus 3 equals 0. And so I get a value of x equals 3 for a 0 of this function. So what that tells me, let me go over here. I don't know what all this function is doing, but at 3, it's either got a local max or a local min. And what I need to do is test on either side of this to see if the derivative is positive, that means the slope is positive, so the function's increasing. If the derivative is negative, that means the slope is negative of the tangent line, so that means the function is decreasing. So let's take a couple of points to test, and I can put any numbers in here that fit. Over here to the left of 3, I'm just going to put in 0 because that usually makes things pretty easy. So I've got negative 4/3 times 0 minus 3, and take the cube root of that. Well, the cube root of negative 3 is going to be a negative something, and we're multiplying it by a negative 4/3. So negative times a negative, that's going to be a positive. So over here, it's rising. I know that it's rising that whole, off to negative infinity here because there weren't any other zeros. For it to stop rising and start falling, there would need to be another local max or min, okay? So, and the same is true over here. I know whatever behaviors on this side, it's going to continue on because there aren't any other points where the derivative of the function is 0. So no other, tops of a peak or low point in a valley. So let's pick a point over here. I'm going to choose 4. So I've got negative 4/3 times 4 minus 3 to the 1/3 power. And 4 minus 3 is 1. And 1, the cube root of 1 is 1. So this actually equals negative 4/3. So the value of the derivative is negative. That means the slope of the function is going to be negative. So this is decreasing. What does that mean about our critical point here at 3? Well, if you're rising, if I were drawing this function, it's rising, rising, rising until it hits 3, and then it starts falling, and it falls forever. So we have a function that looks like that, and our local max is here at 3. So let's see, what do we have to fill in here? Intervals on which f is increasing. Well, all the way over from negative infinity up to 3, not including 3 because at 3 it's neither increasing nor decreasing. And then where it's decreasing is from 3 all the way out to infinity. They also want us to say where there's a local max and where there are local minima. There's just one. And they want the coordinates, so they want an ordered pair. So I know the local max here is at 3. To find the coordinate, I should put that in. 3 minus 3 is 0. 0 to the 1/3 power is 0. And oops, I'm putting it in the wrong function. Haha, of course it's going to be 0 there because that's the derivative. We actually need to put it in here. So negative 3 minus 3 to the 4/3 power plus 8. All of this goes to 0 because this is 0 in here. So it's really going to be the 0.38. So 38 is our local maximum. What about local minimum points? Well, there aren't any. The function is just something that rises until 3 and falls afterwards. There are no local minima. So we would just put none in there. All right, so that is a little bit of work in using the derivative to find where a function's increasing and decreasing and where its local minima and maxima are.